and every 20 years we plan to do a scheduled inspection of under the cover and under lifting the cask and looking at the bottom. We also are going to perform an annual trending of neutron radiation doses at the Pacific perimeter to detect any change in neutron doses. And we're also going to commit to performing a review of our operating experience every 5 years. That review will include a review of each of the elements of the 10 amps, and if one of those elements needs to be updated to reflect the latest information from the industry or the OE review, then we'll commit to do that. Next slide. All right, for structures, we currently do not have what we would call a formal structural monitoring program for our pad. Again, it was non-safety related, how it was built. However, we have done 4 previous inspections of the pad, and each time we've recorded those results and looked back at previous inspections and have identified no aging effects over the course of the last 15 or so years that pad has been constructed. As far as enhancements to that program, we're going to have a new program. Again, we'll do the opportunistic inspections. If ever we lift a cask, we'll look at the pad underneath the cask. And again, every 20 years, we're going to guarantee that we'll lift a cask and look at the pad. Every 5 years, we're going to look at the pad with a walk down, and we'll do that per the acceptance criteria of ACI 349. And again, we'll do the OE review as I discussed previously, and any updates to the pad amp will be made at that time.
Can we go back just one slide?
Absolutely.
The interseal pressure monitor. That is, the amp is just to watch that.
It's a continuous monitoring process. Right. We have low alarms that actuate in our security office, and they notify the control room if one of those alarms come in.
This is Taean. I have one question on spent fuel assembly aging effect. You ruled out probably because of the low burn-up fuel you're considering?
Absolutely. I assume you're trying to get at cladding degradation. Our tech spec, the basis of our tech specs limit us to a cladding temperature of 400 degrees peak center line. And per the ISG, they're for cladding degradation. And that's
okay. Thank you.
And with the interseal pressure brakes, right, and all you would do is refer to your pressure program or
well, you're correct. It's developed years ago that provides the process we go through to identify what's causing harm. We look for helium leaks external to the cask. Ultimately, if we had to take the cover off and check the overpressure tank, we would do that. And we also check the function of the pressure switches. But you're right. If we get the alarm, it's entered in our corrective action process, and that kicks off all of these activities.
I just want to mention having the groundwater monitoring.
Oh, I didn't mention that. That's correct.
Yeah, so we have very benign groundwater, and we've looked at the same results. Did some recent samples, very, very low, but we're going to make a commitment at 5 years. So, would you be checking what you are already doing for the plant?
We're still fine.
And just check
right there. Yeah, pH, if we're going to put that into that system.
Gotcha.
Thanks, Paul.
On 20-year, and what was the basis?
For the cask? For the cask. The bottom line is a lot of that had to do with the result of our lead cask inspection. Our cask have been out there for approximately 16 years. And when we lifted that cask and we looked under the protective cover, it was pristine. When we lifted the cask, we noticed we had some coating defect. However, we did not detect loss of material under that cask after 16 years, even with coating defect. So we felt 20 years was an acceptable frequency for lifting the cask to inspect.
How many?
Yes, I have one more question.
of how many did you administer or pre-application?
Yeah. Thank you.
We're going to get into this.
Okay. All right.
Yeah, he'll discuss that in a little bit.
Okay, go ahead, Kay. Okay, go ahead.
Regarding the monitoring, do you check the temperature changes too, from compared with the initial condition?
Are you talking with respect to the cask?
Yeah, yes.
No, I mean, we don't look at the temperature. When we first load the cask, it's assumed to have design basis fuel at the maximum temperature in it, and therefore it could only decrease it after that due to decay heat. So we do not check the temperature.
Okay, thank you.
Say again?
Question outside the cask.
That'll be every. We're going to continue to do a quarterly visual inspection that we're doing now. That's right. Every 20 years, a scheduled exam where we lift the cask, look under the bottom, and also take the protective cover off and look underneath the protective cover. Yeah, those will be NDE inspections to either VT1 or VT3 as at.
And the current quarterly inspection, is that for tech specs or is that just procedural?
Actually, our quarterly inspection is not in tech specs. It is embedded in a statement on our safety analysis report, however. So it is a commitment. And next slide, please. Tony, I'll turn that back to you.
Okay.
Thank you.
So the North Anna site and the region have had quite extensive environmental review over the years for a number of different reasons. So what we tried to do was to leverage and review that and refer to that number of ERs and EISs over the years to address NRC's earlier conclusions. Primarily, we focused on alternatives such as backing or building, the affected environment around the site, environmental impacts we review again, stated in their previous ISs, as well as our own. Bottom line for this environmental review was benefit there for license for additional.
Okay, that's have a full for the backer, right?
Yes, it does. So as I mentioned from the earlier agenda, big cast inspection, Brian and Jim may follow each other, but Brian is the lead on this aspect of this work. This component for the LRA. Brian, if you'd like to lead off on this.
Okay, so we did, last fall, we conducted inspections of the bottom and top separately of two separate casts. You were there for the bottom inspection. About a month later, we did the top inspections. The report, the application includes the selection criteria for those two casts and how we arrived at the two casts. So the application will spell out how we went through that whole process. Yes, and we talked to you guys in the fall too. So we followed through on that, but all of that's in the application. The visual inspection techniques that we used, VT1 and VT3 of the bottom, the cover itself, and everything under the cover. And the results of those determined that there was no detectable loss material from the base metal, and that they retained all their capability to perform their intended functions. Now, and everything we're going through today will also be in, the rest of these slides are also going to be in the application, but this slide shows the grid system that we used to do the bottom inspections. Now we marked off 6-inch gradients with tape in the horizontal positions, and then inserted a camera on a sled underneath, and every 6 inches. And then where we saw an indication on the camera, we stopped, took a picture, noted how far in the pole was, so we know that's how we came up with the grid. Now you see that every place we took a picture is marked, and the ones that are highlighted and shown on the left, are gonna follow here. But so you can see this shows where we took pictures because there were indications. If you see no pictures in the application of a pristine coating, it's because we didn't take one. If it was pristine, we kept moving. Okay, so.
But you will share our technique and establish that this should look a little bit familiar to help some memory. But to add on one thing that Mike said, we have a number of photos here that we're going to go through. A lot of them are in the application itself. Obviously, we have some, let's say, photo.
Yeah.
Look, it's really nice so you can trend at the time what you're seeing here and seeing if it gets worse or not.
Yes. Yes. Next. Okay, so this is photo GP2. If you want to refer to that on the slide, it's at the bottom in the center on the grid. It's at the bottom on the center. This is a photo of the coating. I'll call it. This is cracking. Okay, this is a cracking phenomenon. There's no the coating is still there. There's no loss of we detected no loss of the material underneath. I'm going to go to the next one. Shows a blister with bare metal, and again, there's no corrosion there, and there was no loss of the material. The pictures are all 6-inch. It's a 6-inch field of view. So that's about 2 inches. Okay. Next photo. This shows the underside of the bottom trunnion. An underside of the bottom trunnion, and this picture shows no paint indications on the paint that there was anything wrong.
Right behind the side of the grid.
This is a picture of a blister without the paint loss. Again, no loss of material from the metal. The pictures we've shown you are from a wide area of the cast. There's some in pretty much every quadrant. Now, this is kind of an overall picture. It shows the height that we lifted, and you can't see much, but it just gives you a general overview of what it looked like for us to work there. So the cart, what was that height?
Could have been 10 inches.
10 inches. We actually had a piece of equipment at the site that was this size and used that paint and was that old. And it was small enough that we could crib it up, and we ran mock-ups underneath of it. We ran the sled underneath and spent 2 or 3 days trying to make sure we did this right, and that we could do it to the VT3 requirements. Okay? With the sled, the lights, everything worked the way it was supposed to.
And the correct visual recognition card for PDE exams is on the bottom of that mock-up to verify that.
Yep.
Oh, that's good.
And including the day we did the inspection, we went back to the mock-up to make sure the sunlight was going to work that day.
What was the concrete visual underneath?
Civil engineer conducted a visual as best he could, walking around the edge and looking underneath. We didn't see anything other than normal shrink cracking.
You had